Thank you, Keith. And thank you, Marcus and Özcan, for organizing this event and being patient with me when I had to reschedule and stuff. Yeah, thank you, and I'm happy to be back here. So like in sciences, you can compare theories in terms of, say, explanatory power, predictive power, parsimony, simplicity, and so on, to choose which theory is better in explaining a certain phenomenon. And there is an idea in logic that is called anti-exceptionalism that says, well, logic is not that different from the sciences, it's continuous with the sciences, and so it should be treated the same way. And if we assume that there is one correct logic, or at least a certain set of correct logics, then we should be able to compare logics in the same sense that we compare theories of some scientific phenomena, right? I'm not going to argue for anti-exceptionalism or monism. I'm just going to assume them just to compare logic. And so we're going to look at some of the theoretical virtues when it comes to logic choice or theory choice in logic. And these are expressive power, generality, topic neutrality, simplicity, elegance, and adequacy to the data, right? To get to the same picture, this is a part 3 of a 4-part project. Don't worry, there's no prerequisite knowledge that you should know about the other project. I'm going to talk about them, at least one of them. So the project started with me and Jonathan Erenfryd from the Buenos Aires logic group. And there we present a logic which we called classical logic of paradox. Maybe it's not the best name, but we're going to look at that logic today. There we showed that you can express a naive notion of truth while avoiding semantic paradoxes. Same with validity. And it can also avoid revenge paradoxes while still being able to express the paradoxicality notion, right? And we also talk about how it fares better than ST in that paper in terms of not having issues of overinternalization. For example, in ST, you can prove for a certain sentence that cut is available for it, that it is valid to operate cut on a carry sentence in particular when it's not. And so you have this mismatch between what the theory does and what the system does, right? So this issue doesn't appear in CLP. Okay, so that was all in the first paper, and we showed that this logic, which, as we're going to see, it's non-reflexive, there is a non-transitive version of it, at least in the sense that there is a logic that makes the same semantical commitment to it. But we're not going to focus on that. In the second project, I show that you can have a standard model of arithmetic, and so you can express what you want to express with arithmetic without going into ω-inconsistency, which is an issue that is faced with very different logics. For example, ST and LP, even though they get the standard model, there are some further issues with them being ω-inconsistent, but that's that project. We're not going to focus on that. And so in terms of expressive power, if those things are correct, then so far there is some expressive power in CLP in terms of being able to express truth, paradoxicality without revenge, other paradoxes, or ω-inconsistency. Okay. In terms of generality, the same data here applies in the sense that if we cannot apply our logic and theories of truth, validity, arithmetic, paradoxicality on pain of triviality or misinternalization, then the logic is not general. And so because it avoids these problems, it is general, at least so far on what we've seen in those projects. Okay. It is often boasted about classical logic that it is at least, even if you say it's not general or it's not doesn't have expressive power, it is at least very simple, and that's one of the main reasons we teach it in classes. But it also elegance because of some properties that classical logic has that are quite appealing. And I'm going to argue against these 2 points, that it is simple and elegant. But before I do so, the main idea here, I want to show further support of CLP's generality and expressive power by showing how it handles vagueness and how it can be a basis of a theory of liberation. And the whole point of this project is to say, well, it is good for a logic to be the basis of theory of truth and paradoxicality and arithmetic and whatnot, but these are not the only theories, as Plumwood have argued. But you want it to also be able to handle stuff like feminism and liberation issues, right? And that's what we're gonna head towards in the final third of the talk. So we're gonna start with theory of vagueness, generally in classical setting, and then talk about the logic CLP, what it looks like, and have a quick illustration of it, and then how CLP handles vagueness and why we're doing that with vagueness. It's because it's relation to the theories of liberation, as we're going to see. All right. So a very simple, naive theory of vagueness makes the following claims. You have a vague predicate that works as a spectrum. So you have things that satisfy the predicate and things that don't satisfy the predicate. And with enough objects, you have a spectrum of things. And so, for example, you can line up all the people in terms of height. You go from non-tall people to tall people in that way. So tallness is a vague predicate, right? And another assumption it makes is that any two adjacent objects in that lineup that you had, they are indistinguishable in terms of that vague predicate. Again, so if you put all the people in terms of height, they're going to be a lot of people in very, very similar height. And so if that person is tall, the next one is tall, which is the third assumption, right? So if two people are indistinguishable in terms of height, and one of them is tall, then the other one is also tall, right? So these are the assumptions that a theory of vagueness makes, a naive one, right? Okay, to see this formally, again, we're thinking in classical setting. Let the vague predicate be a Homo sapien. And suppose we take the Homo sapiens, I don't know, starting from me, I hope I'm a Homo sapien human, assuming that. And suppose somewhere along the line, like Lucy is a direct ancestor, not just a relative, just to make it easier. And so now you have the first animal, which is me, a human animal, is human. And then we have the last one, which is Lucy, is not human, right? She's a human ancestor, but it's a different species. I don't know how to pronounce that species, so I'm not going to try. And then for every adjacent people in this ancestry line, if they are indistinguishable in terms of being human. So me and my mother are indistinguishable from each other in terms of being human, right? And so what we call the tolerance principle, if I am indistinguishable with my mother in terms of being human, and I am human, we can conclude that my mother is. And with these just these four assumptions, classical logic is trivial. To see this, this is the first assumption that I am human. This is the assumption that I am indistinguishable from my mother in terms of being human. With the principle of tolerance, we conclude that my mother is a human, and my mother is indistinguishable from my grandmother in terms of being human. So my grandmother is a human, and we go up the ancestry line until we reach Lucy, and then we prove that Lucy is also human. But remember, in our assumption that Lucy is not human, and so, as Plumwood would say, a contradiction is the highest punishment in classical logic. And so, with that contradiction, anything follows in classical logic. You have the empty sequence. Also, I forgot to say this, if you have clarificatory question, ask me during the talk, that's fine. Substantial ones probably at the end. All right. So unless there is good reason to reject any of these assumptions, classical logic is inadequate to the data. But importantly, it's that in logic, it's not like science where two theories can share the same exact data, because whatever data you have, it's not going to be independent of the presupposed logic. As an example, if I want to say in classical logic, so if I want to reject assumption one and say, oh, I am not human, reject the claim that I am human. In classical logic, that means we have to conclude that it is not the case that I am human, right? Rejecting a sentence, you get its negation. Unless, of course, that theory is non-prime and negation incomplete. But then that introduces issues of expressibility. So now you have things that don't fall in either disjunct, but you cannot talk about them. Okay. So I'm going to introduce logic CLP, and we're going to return to these claims. And we're going to see that logic CLP, just to give you a heads up, it's going to deny the claim that in two items next to each other are indistinguishable, in the sense that it will always be true. That's not going to go through. Okay? And we're going to see why and how would that work. Okay. The logic CLP, we start with a language of first order language, even though in this talk, we're just going to work with the quantifier-free fragment of the logic. So we have negation, disjunction as primitive, and inverse quantifier, and the rest are defined in terms of them. What is odd is we add a primitive operator. It's kind of hard to see from where you're sitting, but this is a Penrose triangle, and it's going to stand for whatever is paradoxical. I'm going to keep calling it tribar, because in LaTeX it's tribar, and sometimes I forget, and I keep saying tribar. So if I say tribar, I mean this Penrose triangle, and we're going to see how it behaves. Okay? The logic that we're going to work with is going to work with sequence and meta-sequence. And sequence, if whoever familiar with sequence calculus, you work with sets of formulas or multi-sets of formulas. So it's an ordered pairs, and we're going to write them with an arrow. So it's an inference between formulas or sets of formulas. But we're also going to define meta and sequence. And so you have sequence, not just of formulas, you have sequence of formulas, sequence of formulas, and so on. And so you have a logic defined like in a whole, I don't want to say hierarchy, but it's all the way up the same way, as we're going to see when we introduce validity. That being said, we're only going to work on the sequence and inferences between sequence, so we're not going to go too far up. Model theoretically, we have a domain interpretation function. These are all standard in non-classical logics, pre-valued logics, except at the end. So you have for every predicate an extension and anti-extension. If something is true of it, you put it in the extension. If something is false of it, you put it in the anti-extension. But we have a third value, and so whatever it's not in either extension or anti-extension, so it's neither in them, it's going to get the value n. And if it's in both of them, it's also going to get the value n. So it's going to be both gluffy and gappy at the same time. Okay. Interpretation of the connectives is just strong cleaning. So you have, for example, disjunction, you take the maximum value where n is treated as half. And so if you have 1 or anything, it's going to be 1. So whichever value is higher, you're going to choose, right? This is our weird operator, and it's just going to get 1 when phi is n. Otherwise, it's going to get a 0. Okay. So it is important to notice that this is a bivalent or a Boolean valued operator, and so it will always get 0 or 1, never gets an n. And so if you apply it twice, you're going to get all zeros, so you get the constant bottom. So it's derivable rather than primitive, and the negation of it, you get top. Again, we're not going to talk about quantifiers, but it's just standard strong clean. Okay, validity. We say a sequence gamma out of delta is valid if and only if there's something in gamma that is 0 or there's something in delta that is 1. And the same thing we do it for meta and sequence, where we evaluate sequence just the way we evaluate conditionals, so still strong cleaning between conjunctions of gammas and disjunctions of deltas. Okay, so that means the logic is consistent all the way up. And if anyone who's familiar with the logic TS, this is very similar to TS. It's saying if you only have n's, then that's a bad thing. If you have 1 to 0, that's a bad thing, right? You need at least a 0 in the antecedent or a 1 in the consequent. Right? But it is important to note that it is not TS. It is non-reflexive in the sense you don't have phi entails phi, like TS, but it's not empty like TS. And often TS, the works of, say, Rohan French, and other people who talked about TS in the Buenos Aires group, and Bruni and Rossi, they often present TS as that a non-reflexive logic, and so it's empty on the first level, but on the upper level it's a different logic, and so you gain stuff back. But I think that's the wrong approach. I think you have to have logic consistently all the way up so that you don't get metainferential paradoxes hunting you back. And in fact, Rohan presents a problem which says that there's a metainferential paradox, and he suggests as a solution, maybe it should be non-reflexive all the way. So in a sense, it is working as kind of a recaptured TS all the way up. But I don't like saying recapture because I don't think TS would work as a base logic. This should be the base from the beginning. It's not we started with a different logic and then try to capture things back. Okay. It just depends on how you talk about classical recapture in that sense. Okay, so the axioms, proof theory. We don't have reflexivity, but we have this. And so when we read reflexivity, we can read it in the sense either phi is false or phi is true, but that's not the case in our logic. You have third value, and so you need this part to say either phi is false or phi is true or phi is neither or both, right? Whatever option you choose. This one is derivable from these rules, but I just kept it there to see that you have reflexivity once you have the tribars in both sides. Okay. Again, it's derivable because this rule tells you can pull that to the left, and then you pull that to the left, you contract, right? And then you have tribar and tails tribar. Operation rules are same that you find in many other logics. There's nothing special about them. They are context sharing. Technically, it should be, these operational rules should go both ways. So it should be invertible rules for completeness. But for now, we're not going to use that much in our proofs. But technically, this should be double lines. Again, conjunction, conditional are same as always, context sharing ones. You have weakening, contraction, and cut, full of them. So the only thing that technically changed is your reflexivity. Okay. Doing things that way, we can define a truth predicate. So right now, I'm just going to do truth predicate and show you how it looks with the liar, just to have a toy example, a flavor of the logic, but we're going to move on from it afterwards. So we have a fully naive notion of truth predicate. So you can put it on each side and it always get the same value as the thing without the truth predicate. Okay. For paradoxicality, it's going to behave as the tribar. And so you can go from a tribar sentence to a paradoxicality sentence. This is, so a lot of non-classical logics are okay with the first part. They're not okay with the second part because that could reintroduce revenge. But I'm gonna wave on why there's no revenge here, but if you want more details, I can show you why it should not be there. Okay, in terms of the liar's paradox, we define lambda as not true lambda. So a sentence saying of itself that it is not true. If you've ever seen the liar's paradox in classical sequent LK, it's the same thing, but with a leftover tribar. Okay? And so when you end up, instead of the empty sequent, you end up with a tribar lambda. And from there, you can say that lambda is paradoxical. So whatever can get you to the empty sequence is going to be paradoxical. So a carry sentence with a absurdity as its consequent, it's going to turn out to be paradoxical. You can show that. With a true consequent, no, it's a true sentence. With an arbitrary consequent, it's undecided. One important thing to note here is that the definition of lambda move, technically it's a form of reflexivity and cut being employed. Depends on the way you set up your naming device. But in the other project I was talking about, I do the naming device via diagonalization lemma. Though we don't have regular diagonalization lemma, because it's a non-reflexive logic, you have a weaker one, where you also have a leftover tribar. So technically, these definition moves where you switch from not true lambda to lambda should reintroduce tribar here. But because we can contract in this example, we went too quickly. Okay, so how does that relate to vagueness? Well, the first two assumptions with vagueness, for example, I am human and Lucy is not human, the logic is okay with that. That's fair. It says, okay, we can assume that I am definitely human. We can assume that Lucy is definitely non-human. However, when you say every two items next to each other are indistinguishable in terms of being human, the logic pauses, right? Because if the sentence receives the value n, that is not true and not false, so it's somewhere in the vague area or the gray area, then the logic would tell you it's not even identical to itself. Again, we're rejecting reflexivity, we're rejecting going from n to n, so it's not going to be identical to itself unless it is a bivalent, it gets a bivalent value, a Boolean value. Okay? So it's going to reject assumption 3, but it has a weaker one. So it's going to assume that I am human. Lucy is not human. The weaker indistinguishability assumption is that the two adjacent objects are indistinguishable as long as both receive either ones or both receive 0. Okay? And technically also, the tolerance principle should also be qualified the same way. I'm going to say why I didn't put the restriction here in the next page, because there's a different way of presenting the tolerance principle. So now the derivation, I didn't expect the screen to be that small, but I'll read it out loud. This is the assumption that I am human, okay? And now says, I am indistinguishable from my mother in case that I'm not, the sentence I am human is not paradoxical, doesn't receive that value n, and the sentence that my mother is not human doesn't receive the value n, right? And so you go through the same proof as in the previous one, except you're left out with leftovers now. Now, I cannot conclude that my mother is human. I can conclude my mother is human on the condition that me being human is a definite thing, and whether my mother is a human is also a definite thing. Okay? And because of our assumption, we're assuming I'm definitely human, we can get rid of that part. And now it just says my mom is a human on the condition that it is a definite thing. So she's not in the gray area. And so you can now walk through all the steps through the ancestors. You can say, yeah, I can say, for example, my mother is definitely a human, so I can get rid of that try-bar, right? And I can get the fact that my mother is human. I'm going to reach a point where a sentence that says that subject is a human, it's neither human nor not human, or both human and not non-human. And so in that instance, we cannot say that they are human. And so we cannot put the chain together all the way to Lucy. We stop a way earlier point. Okay. We talked about this. So you can only go all the way up if you are certain that the predicate is a bivalent predicate, that you are certain no object with that predicate applied to can be in the gaps or can be in the gluts. So, for example, the predicate is a prime example of such predicate. That's your tongue twister of the day. So, it's, for example, a number is odd. It's either odd or not odd. It cannot be both. It cannot be neither. And so you can get rid of all the try-bars here. Okay. So how does that all relate to theory of liberation? Before saying how it relates to the theory of liberation, I want to introduce what Val Plumwood argues for in her paper to the politics of reason towards feminist logic. It's a very good paper. I'm going to briefly sketch her argument. I'm not going to go in details, but I highly recommend you looking at the paper. So Val Plumwood argues that all oppressing groups capitalize on establishing and sustaining what she calls dualisms. So if you have groups of oppression, say men and women, or human and non-human animals, or rational or irrational animals, colonizer and colonized, white and non-white, they all work in the same way in terms of them being have characteristics of what she calls dualism. So dualisms are not just dichotomies between two groups or two concepts, but rather they highlight existing patterns of differences between the oppressing group and the oppressed to ground the hierarchy between the groups. And how does that work? Well, Plumwood says there are 5 features of dualism, and that would distinguish them from just mere dichotomies. These 5 features, first one is backgrounding. The oppressor relies or depends on the oppressed, yet portrays the oppressed as inessential. For example, say between upper class and lower class or working class, the upper class, say, just a toy example, a CEO depends on the workers, right? But the workers are treated as inessential, replaceable, you can get rid of them, but what is essential is whatever the CEO does, or whatever the other part does, the oppressor does, right? Another example, I think, if I remember correctly from the paper, Plumwood says, well, the idea that the outdated idea of how men go to work, do real work, while women stay, do inessential work at home. So that kind of portraying the other one as inessential, what they're doing, even though the first one depends on the other one of what they're doing, right? The second feature is what she calls hyperseparation or radical exclusion. The oppressor exaggerates the difference between the two groups and downplays any commonalities between the two. And so you often see, again, sexist remarks of taking women as emotional while men as rational. And so you separate the two. Same thing with, say, human and non-human animals. You have they count humans as rational while animals are all counted as irrational, right? And so you want this to separate these two groups in the sense that the oppressor wants to say you're nothing like that. Right? And Plumwood says you only need a minute difference between the two to create that hyperseparation using Leibniz law. Because Leibniz law says you have one feature that is different, then they're not identical, and so you separate the two. Okay. Third is relational definition. The oppressor comes first, and the oppressed is defined by the oppressor as if the oppressed group would not have existed without the oppressing group. So, for example, again, a biblical example is that Eve came from Adam. Eve's own existence depended on Adam, right? And that's wants to highlight how the first one is ontologically comes first, and the second one depends on it. But also in terms of, if you saw the examples here, white came first, and everyone else, non-white, defined through white people. Same with human came first. Every other animals were defined in terms of the first one. For instrumentalism, the oppressed serves the needs of the oppressor, rendering the oppressed group as a mere instrument. You see that, for example, in Kant's deontology when he say humans are rational and only that is rational has its own end. Everything else, non-human animals don't have ends in themselves. And so that creates the idea of you can use them as merely as a means to your end, right? But of course, that's not just the example of humans and non-human animals. All the other examples work that way. And finally, homogenization is the idea that everyone else is the same. The oppressor and the oppressed are very different, but the oppressed are all the same. And we saw, again, through the relational definition, we had white, and then we had non-white for every other race, right? We put everyone who is a person of color in one group, even though there are a lot of differences. So you ignore the differences between the oppressed group. Okay. I'm going to focus in this talk only on hyperseparation, homogenization, and relational definition. I'm going to leave backgrounding and instrumentalism, though see Plumwood's arguments on how classical logic still have these features. I think in terms of backgrounding, she talks about assumptions, suppressions, but we're not going to deal with that. I'm just going to focus on how classical logic hyperseparate and homogenize and has relational definition. Of course, these are the ideas of Plumwood to begin with. So she argues classical logic perpetuates the aforementioned feature, creating a natural home for dualisms. From our perspective, this relates back to vagueness, because, at least for the characteristic I'm talking about, because if you want to express vagueness in classical logic, if you have a spectrum of things, and in classical logic you only have two bins, either it or its negation. And so you are bound to first hyperseparate, even though they can be close to each other, similar to each other, you have to put them in different bins. And whatever that different bin, they all collectively, even if there are differences between them, are in the same bin. Right? And if you notice all the examples we gave, men, women, and white, non-white, human, non-human, they're all spectra. They're not clear-cut like odd, even numbers, right? That's because classical logic's failure to deal with spectra, it is bound to create dualisms of mere dichotomies. It is forced to hyperseparate and homogenize. Plumwood faced some pushback, especially lately. For example, Gillian Russell argues there's no special relation between dualisms and classical logic, and she provides the example of odd and even numbers to show that no dualism is created. I'm going to read the quote. She says, if we take the set of natural numbers as our domain, we can interpret the non-logical one-place predicate E as the set of even numbers, and the odd numbers will then be those of which not E is true. But this doesn't mean, but this doesn't result in a precarious even odd or even not even dualism, because there are no consequences in terms of homogeneity, backgrounding, hierarchy, or instrumentalization. The odd numbers are not being oppressed. But this is not a fair reading or charitable reading of Plumwood. He never argued that classical logic creates dualism out of every dichotomy, right? But what makes this example a mere dichotomy rather than dualism? Again, it depends on the predicate. The predicate you were working with is bivalent. They are not spectra. You cannot say something is both odd and not odd at the same time, or neither, right? And so In such bivalent domains, of course, classical logic is going to excel. But not all domains are bivalent. In fact, most the bivalent domains are the exceptions, they are not the norm. Right? So once a non-bivalent is thrown towards classical logic, it is bound to create some characteristics of dualism, because again, of its inherent bivalent nature. And so we know from this that classical logic has an inherent bias that cannot be removed. And if it has an inherent bias, it is not topic neutral. Okay. Russell returns to the relational definition and concedes that the interpretation of being not even depends on the interpretation of being even. However, that is different from saying odd numbers depend on even numbers. We can flip the relational definition. Instead of having even numbers depend on odd, we can have odd depends on, it doesn't matter which one comes first. That's what she's saying. So suppose we combine classical negation with predicates that already have a dualistic baggage built in, for example, male, not male. The result may be dualism, but since classical negation can also be used without these consequences, as in the even, not even example, we know that it isn't the classical negation that is responsible for these features. But to me, that screams as a fallacy, because it's analogous to someone who's saying, well, classical logic with a fully transparent truth and a naming device is not paradoxical because there are instances where it's not paradoxical, or instances of the T schema are safe, and so it's not classical logic that is creating those problems. But that doesn't follow. Okay. As Francie Mangrabiti puts it, she says, Plumwood is not suggesting that every classical dichotomy, let alone the odd-even of piano arithmetic, is a dualism, nor does her argument against classical logic requires it. The central point is not that classical negation or classical logic in general creates dualism everywhere, but rather that the default status of classical logic contributes to the naturalization of existing dualisms, insofar as dualisms have a classical logical structure. And here we're in agreement with France. And to support their argument, suppose we represent identifying as a man with an M and identifying as a woman with a W. It seems all these dualistic features are gone. Now, W is not defined through M, nor M is defined through W. Things can be in both concepts. Things can be in neither concept. And so it seems like this supports, this seems to support Russell's argument that these dualisms is not classical logic itself, but rather our misapplication of classical logic. Well, there's a question of how are we sure that these two concepts are within the same concept of gender? I don't think that is going to be expressible in classical logic unless maybe you go to second order. But leaving that aside, I think this misses the point. So while this approach avoids dualism, there are some problems. The point, as flagged by Francie, is that classical logic facilitates the establishment and sustaining of dualism, right? And so, to circle back on how classical logic is simple and elegant, even if we say that this is available for the classical logician, the fact that it is so easy to misapply it and have those create oppression via classical logic, that alone should raise a red flag, right? If it is extremely easy to misapply a logic in ways that promote oppression, then that logic is neither simple nor elegant. The virtue of simplicity does not just boil down to being easy to use, but it must be also difficult to misuse and abuse, right? And similarly, there's no elegance when a system perpetuates ignorance, exploitation, and oppression. Hence, classical logic, as we have seen, fails as the basis of the theory of liberation, just as it failed in vagueness and other theories. And so, as Francie points out, when it comes to Plumwood herself, her argument is this. Since logic aspires to be universal, it should apply to gender as well. So the fact that classical logic, or theory of logic, deals poorly with gender, as it deals poorly with other theories as well, is evidence for it not being the correct theory. For the correct theory or logical system not being classical after all. This leaves room for a better theory whose subject remains a logic that is in fact universal. And that's what we try to do in this paper, is to say, well, CLP could be a good candidate for this. Unlike classical logic, the default, it does not assume bivalency by default. In fact, for every concept, there is a possibility that things fall in between or in the gaps. Okay. And so in order to get bivalence concept in CLP, you have to first prove that there's nothing in the gaps, there's nothing in the gluts. And so as a result, this logic does not make it easy to homogenize and hyperseparate. On the one hand, there's still some kind of relational definition in this logic. And that could be seen as a problem. Okay, I'll try to go faster. I thought it's an hour and a half, right?
The whole thing.
The whole thing, yeah. Okay. There's some relational definition, but it's not a hierarchical one, in the sense it does not ontologically depend on the other. Okay, so we can represent one end of the spectrum as GX, call that, say, is a woman, or you can read it as only a woman, and then not GX, the other end of the spectrum is a man, or identifies as a man. Okay. So, of course, we can do the WM part, as I suggested earlier, but that, I think, is the wrong move, because you wouldn't be sure that it is still within the same concept of gender. Okay. And then we have a non-binary operator, which is playing the role of tribar. And so that symbol in front of GX is read as X is non-binary. So now the default assumption is for any person, that person is either a man, a woman, or a non-binary. Also, in terms of relational definition, we didn't really need negation to define the other side, because as you saw here, there's no negation in reflexivity, but it's implicitly there. So we don't have to explicitly use negation to express the other side of the spectrum. And also, even though I'm using the example of gender, it works with all liberation spectrums. So this is in line with Plumwood's reason for advocacy of relevant logic, though this is not relevant logic, but she uses something similar in terms of how it's not relational or hierarchical in terms of relational definition. She says the resulting concept of otherness can be modeled by a number of natural, widely used otherness relations, such as the other side, which have no hierarchical features. And that's what's happening here in our logic. And this is also not news. It is also similar to Sarah Ehan's work, which I'm going to discuss briefly at the end. But she uses a negation-free connexive logic as a candidate for a theory of liberation, and because it's negation free, you don't have negation showing up as a relational definition. But again, it might be argued that it's implicitly in her concepts of proofs and refutations. She has double horizontal line for refutation, one line for proof. Okay, thus, if you want to say that A is a man, we must find a derivation that not only eliminates the possibility that A is a woman, but also the possibility that they are non-binary. And other things that would show up in this logic is that if you establish that A identifies only as a woman, then you can show that they don't identify as a binary, a non-binary. And also, if you show, well, you can prove the sequence that if A is neither a man nor a woman, then they are non-binary. And if A is both a man and a woman, then they are non-binary, but not the other way around. Can I say from non-binary, then they are both a man and a woman? Okay. And moreover, to tie it back to vagueness, to say that a person's A's gender is indistinguishable from person B's gender can now only hold if both A and B identify as only a woman, and or they identify as only a man. And so if they identify as non-binary, you cannot say that they are indistinguishable in terms of gender, because after all, non-binary is an umbrella for a lot of genderqueer different possible genders that people identify with. Okay. One worry is that, okay, since the non-binary is an umbrella term working here, it might be that there's still homogenization, even though it's not a homogenization in terms of everything that is a woman compared to everything that is a man. There's still a homogenization in terms of non-binary. And so both someone who, for example, identifies as agender or someone who identifies as bigender are still lumped together. And so that seems to be another problem where they are all, the differences are not taken into considerations. One possible response is to say, okay, maybe we find a weaker logic somehow that can sever the umbilical De Morgan cord between the two, so that you can have people to identify as agender, you can have people to identify as bigender. It's not one umbrella for them. But I think that is the wrong direction. Not only we would lose the umbrella term, maybe you can define it through other means, you're still ignoring all the other possible genders. And so just having these two categories is not going to solve the issue. Because you have people who are non-binary but don't identify as either agender or bigender. A better solution maybe is to keep it as is, and so it's an umbrella for non-binary, while providing further predicates to work as for other genders. And you have all the other predicates be, if you have such a predicate, say agender, then you are non-binary. But don't read it off just from the neither option to non-binary. Okay, I will close up very shortly with a few comparisons with other logics or other proposals that people said could work as a basis of theory of liberation. Plumwood argues for relevance logics, but she didn't say which one she's arguing for, so I'm not gonna argue against that. We have Maureen Eckert who argued for FDE, and we have Sarah Ihan who argued for a bilateral connexive logic 2C minus. In terms of FDE, it has some problems. First, we agree with Eckhart in terms of how classical inferences also seem inadequate for capturing the resistance to and the destabilization of binary gender kinds that is inherent in gender queerness. So we are on the same page, and she suggests FDE as a possible logic of liberation. Since if you're not familiar, FDE is a four-valued logic. You have same as us with an n value, but it's separated from the b value. The neither value is separated from the both value. There are two major issues. And I'm going to argue that both issues show that it's inadequate of representing non-binaries. First, suppose we have an individual who identifies as bigender in the sense that they identify as both a man and a woman. It seems natural, as we mentioned earlier, maybe to present them as B is G and B is not G, where G could be maybe a woman and not G is presenting a man, right? Unfortunately, in FDE, that if our person here, B, is bigender, then saying of them being bigender is not going to come out as true. It's going to come out as both true and false, which is not something that we wanted. Because in FDE, the B value is going to get a B. The same applies if someone identifies as agender. Saying of them that they are agender, it's not going to come out as true. In fact, it's going to come out as neither true nor false. Still not the thing we wanted. We wanted to say something truthful about their gender, and that's not reflected in FDE. So it goes against Eckhart's wishes, even though she does say it has to come out as true. It does not come out as true. Second, where Jeffrey is Eckhart's example of someone who identifies as bigender, he says, recalling that because Jeffrey identifies as both a man and a woman at various points in time, LEM fails as it is false and misgendering to truthfully claim that Jeffrey is a man, but it is also false that Jeffrey is not a man. Jeffrey is both. Even though LEM fails in FDE, that is true. Conjunction elimination does not fail in FDE. That means if Jeffrey identifies as both a man and a woman, we will make the fallacy of saying that Jeffrey is a man simpliciter or Jeffrey is a woman simpliciter. And that's something that we don't want. Once again, in CLP, conjunction elimination does not hold. Unless it has been established that the person is not non-binary. So even if we read the non-binary operator as both a man and a woman, that cannot separate. And for Sarah Eisen's logic, the bilateral connexive logic without negation, it is a contra-classical logic. That is, some theories of this logic are not theories of classical logic, and vice versa. Some theories are, or some validities of classical logic are not validities of this logic. Unlike our logic in FDE, which are subclassical, in the sense, whatever is valid in our logic, well, technically, if we didn't have the operator, it's valid in classical logic, but not vice versa. So it's a weaker than classical logic. And so one argument that Sarah puts is that, well, it is worth pointing out that unlike most alternative logic considered, with our contra-classical system, we have a logic which is not even a subsystem of classical logic. If we do consider Plumwood's criticism of classical logic valid, it seems desirable to free ourselves as rigidly as possible from it. I think that's not a very good argument, because still classical logic gets things right in bivalent situations, especially in mathematics and arithmetic. And so we want to retain that part. So she says that people who do classical recapture are almost being apologetic towards classical logic. The idea is not we're being apologetic, but rather if you diagnose the part of classical logic that is doing all the bad things, and you get rid of that, and that gets you the theories that you want, then maybe that's a candidate for a logic that works for liberation. So you don't have to get rid of or go as far as possible from classical logic to avoid the problems of dualisms. Right? So just in other words, what I'm trying to say is that if a drastic departure from classical logic is required, then you do drastic departure. If not, then it's not. So just because classical logic has problems, it does not automatically favor something contra-classical compared to self-classical. One last problem, I'll say that quickly. She says, the systems considered in feminist logic so far, mine included, usually stayed within propositional frameworks. Given my examples, though, an extension to first order logic seems like a natural choice to model queer feminist concept. And that's what we did. We started with a first order because we think it's related to vagueness issues. And so without her presenting things in terms of first order, it's hard to evaluate comparatively between the two logics. Again, this is not to say that her proposal doesn't work, or our proposal is the only correct one. It's still, we're just comparing things and trying to get the best approach. It might be this approach, it might be another approach, still open in the air. I think more research should be done about theories of liberation, the same way a lot of research has been done with semantic paradoxes. So we have shown CLP's expressive power and generality, and arguably topic neutrality in the sense it doesn't make those implicit biases, and maybe simplicity if you find classical logic with leftovers to be simple. Yet it's not simple in the same sense of classical logic of being easy to misuse or abuse. It's very hard to abuse. Last question that I want to ask is, if classical logic is not general, not topic neutral, not simple, not elegant, not adequate to the data, and lacks expressive power, why is this still taught as the default logic? Thank you.